Alright, so this is number 5.15a from the review, and it reads the weekly repair cost x for a certain machine has a probability density function given by this with measurements in hundreds of dollars. So find the mean and variance of the distribution of repair costs is part A, which is the only part that I said you guys have to do. So for the mean, let's first calculate the mean, right? So this is the expected value of x. And the general formula for this is what? We want to integrate from negative infinity to infinity x times our density f of x dx. So in our particular case, this is going to be equal to, remember, the integral from 0 to 1, because in places other than 0 to 1, right outside of that, our density is going to be equal to 0, so this integral is just going to be equal to 0. The x isn't going to matter. X times 0 is going to be equal to 0. So this is equal to the integral from 0 to 1 of x times our density, which is 6x times 1 minus x dx. So let's pull out the 6 and kind of distribute in this x squared here. So this is going to equal 6 and then times the integral from 0 to 1. So I distribute in the x squared. I have x squared minus x cubed dx. So now this is 6. So when I integrate this, I'm going to add 1. So x cubed over the new power of 3 minus, I do that again, x to the 4th over the new power of 4. And I'm going to be evaluating this from 0 to 1. So this is going to be equal to 6. So I evaluate this by plugging in the top number and subtract off plugging in the bottom number. So this is going to be 1 cubed over 3, so 1/3, minus 1 to the 4th over 4, which is just 1 over 4. And then when I plug in 0, this is going to be 0. So now I have 6 times the common denominators will be 12. So this is 4 over 12 minus 3 over 12. So that should be 1 over 12. So this is going to be equal to 6 times 1 over 12. So this is going to be equal to 1/2. So that is our mean. Now for the variance, we're going to want to calculate what? We're going to want to use the computational formula for the variance. So the computational formula for the variance is, remember, expected value of x squared minus the expected value of x, quantity squared. So to use this formula, we need to calculate the expected value of x squared. So let's do that. So the expected value of x squared, by definition again, is going to be equal to the integral from negative infinity to infinity of x squared times f of x dx. And again, in our particular case, this is going to become the integral from 0 to 1 of x squared times our density, which is 6x times 1 minus x dx. So let's again pull out the 6 and distribute in this x cubed now. So this is the integral from 0 to 1, and it's going to be x cubed minus x to the 4th dx. So we integrate this, we get 6. So we're adding 1, so x to the 4th over the new power of 4, minus again adding 1, so x to the 5th now over the new power of 5. And we want to evaluate this from 0 to 1. So this is going to be equal to 6. I plug in 1, I get This is going to be 1/4 minus 1/5. And then I subtract off plugging it in 0, but that is going to be 0. So now, again, I should get common denominators here. So this is going to be 6 times 5/20 minus 4/20. So that's 1/20. So this is going to be 6/20. So I guess that's 3/10. And that's our expected value of x squared, right? So, but again, we need to plug that into this computational formula for the variance. So we have that the variance of x is going to be equal to the expected value of x squared minus the expected value of x squared. And again, we have all the pieces that we need at this point. So we can just plug them in. So this is going to be 3/10 minus 1/2 squared, which is 1/4. So this is 3/10 minus 1/4. So I think again this is going to be 20ths. So this is going to be 6/20 minus 5/20. So our variance is going to equal 1/20. And that is it for this problem.